During the night of January 14th to 15th, 2025, the Russian military launched a large-scale missile and drone attack on Ukraine's energy infrastructure. According to reports from the Ukrainian Air Force, Russia fired 74 Shahed drones, along with other attack drones, and 43 missiles toward Ukraine. Meanwhile, Ukrainian President Volodymyr Zelensky was meeting with British Prime Minister Keir Starmer. During the meeting, Starmer announced that the United Kingdom would provide Ukraine with additional mobile air defense systems to counter Russian airstrikes. At that moment, a Russian drone approaching the Ukrainian presidential residence was shot down by air defense forces. However, what was strange was that the drone neither exploded nor emitted smoke upon being hit. Instead, it silently fell from the sky and crashed onto an innocent civilian's private car. A post-incident investigation of the crash site revealed something even more unusual. This drone was not carrying any explosives. Instead, inside the drone was a peculiar plastic sphere. What exactly was going on here? In fact, this unarmed drone is actually a decoy drone, specifically designed to mislead ground-based air defense forces into wasting their firepower, thereby creating openings for real attack drones to penetrate enemy defenses. During airstrikes, the Russian military first deploys decoy drones to lure Ukrainian air defense missiles or interceptor aircraft to the wrong targets. This diversion allows actual suicide drones or cruise missiles to break through Ukraine's air defense network with a higher chance of success. Additionally, these decoy drones can be deployed alongside suicide drones, making it more difficult for Ukrainian air defense systems to distinguish between harmless decoys and those carrying actual warheads. Since the summer of 2024, the Russian military has actively incorporated decoy drones into their airstrike strategies to reduce costs while increasing attack effectiveness. Currently, Russia primarily utilizes two types of decoy drones, one known as African Bureau and the other called Splendid Jade. The construction of these drones is fairly rudimentary and inexpensive. Their bodies are made from foam plastic and plywood, held together with industrial adhesives and hot glue with an outer layer of spray paint. This simple and cost-effective design allows Russia to mass-produce these drones at a minimal cost. At this point, some may wonder, why not equip decoy drones with bombs so they can also attack? The answer becomes clear when examining the structure of these drones. The first type of decoy drone to appear was the African Bureau drone. Its exterior design is almost identical to the Iranian-designed Shahed series drones, which the Russian military frequently deploys. The reason it was named African Bureau is likely linked to the Russian military's naming conventions, as the Shahed 131 and Shahed 136 drones were designated Jiran, in geranium, by Russia. This drone's control system consists of only two main circuit boards. The first circuit board handles drone navigation. The primary control chip is a Swiss-made U-Blox GPS module, which is also compatible with Russia's GLONASS positioning system. On U-Blox's official website, a single chip costs $31.50, but some suppliers sell them for as low as $5 to $8. At the center of the board is a black STM32F407 microcontroller unit, MCU. Designed by ST Microelectronics, this MCU is widely used in various applications. In this drone, it mainly manages flight control tasks. On the international market, an STM32 microcontroller typically costs around $5. Additionally, the circuit board includes a gyroscope and accelerometer chip, though its specific model is unknown. However, cheaper versions of such chips generally cost around $5. To the side, there is a blue circuit board, which is actually an XL6009-11 module. The blue circuit board previously mentioned is actually an XL6009-11 module. This component is designed to convert low-voltage DC input into a maximum output of 60 volts. Based on its design, the XL6009-11 module appears to be an off-the-shelf commercial product with an estimated cost of around $2. Looking at an internal image of the African Bureau drone, we can see nearly all of its electronic components. Apart from the navigation and flight control modules mentioned earlier, here are its key internal features. At the bottom left, there are 12 lithium-ion 1865 battery cells which provide power for the entire system. At the top left, there is a 4G signal modem module. According to Ukrainian experts, this 4G modem module is designed to connect to Ukraine's mobile network. The African Bureau drone even contains a Ukrainian SIM card, which allows it to access local telecom networks. Through the internet, it transmits its location data and camera footage back to the Russian military's control center. By analyzing where these decoy drones are shot down, Russian forces can gather intelligence on Ukrainian air defense positions. This enables subsequent waves of suicide drones to avoid these locations and increase their chances of successfully reaching their targets. In total, including all internal electronics, a plywood and foam airframe, and a small air-cooled gasoline engine, the entire production cost of an African Bureau drone is estimated to be no more than $350. This extremely cost-effective tool for Russia now, let's take a look at the Splendid Jade decoy drone, which was first identified in January 2025. The name Splendid Jade might sound unusual, but in reality, it refers to a type of cactus that is native to Brazil, Argentina, and other South American countries. Why did Russia name a decoy drone after this plant? The reason is quite simple. The scientific name of Splendid Jade is Parodia, which translates to Western imitation, a fitting name for a decoy drone meant to mislead air defenses. This also aligns with Russia's long-standing tradition of naming military equipment after plants and flowers. Structurally, the Splendid Jade drone is even simpler and cheaper than the African Bureau drone. It no longer uses the Shahed-style airframe, but instead adopts the most basic straight-wing design. At first glance, it looks more like a cruise missile or even a glide bomb. To reduce weight, lower costs, and increase range, its main external structure is still made from plywood and foam plastic. Its internal circuitry is even more primitive than that of the African Bureau drone. Some key differences: it has no onboard camera, unlike the African Bureau drone. It does not contain a 4G communication module. Instead, it uses an L2A module. The L2A module, meaning long range, is commonly found in Internet of Things IoT devices. It operates on the 433 MHz frequency band, allowing for low-power, long-distance transmission. By now, we have a general understanding of how these two types of decoy drones are constructed. However, one major issue remains. Even though these drones mimic the behavior of real suicide drones, and the African Bureau drone is nearly identical in appearance to the Shahed, a visual resemblance is not enough. A decoy drone might fool the human eye, but can it deceive radar systems? Since these drones are designed to be low cost and lightweight, they lack metal components. This means their radar signature is completely different from that of a real, large military drone. So how does the Russian military solve this issue? The answer lies in the two mysterious spheres located on the underside of the drone. Take the Splendid Jade drone as an example. Inside its structure, there are two 3D printed plastic spheres. Beneath each plastic sphere, there is a layer of aluminum foil, commonly used in baking, which is held in place by plastic wrap. At first glance, these plastic spheres appear insignificant and extremely cheap, but they actually serve as Lundberg lenses, a clever radar deception tool. A Lundberg lens is typically a multi-layered sphere, where each layer is composed of materials with different refractive indices. Moving from the core to the outer surface, the refractive index gradually decreases. The function of this specially designed sphere is to focus incoming electromagnetic waves of a specific radar wavelength onto a single point on its surface. Due to the principle of optical reciprocity, these focused radar waves are then reflected back in all directions. US military applications and Russia's adoption. Back when the United States was developing the Aegis combat system, active phased array radar technology was still in its infancy. To compensate for this, the US military implemented the RM-50 low-peak missile project. The SPG-59 radar system, which was used to guide low-peak missiles, utilized Lundberg lens technology to enhance radar targeting. The plastic spheres found on Russian decoy drones are essentially Lundberg lenses applied in a modern military context. The aluminum foil underneath the spheres acts as a signal reflector. When radar waves pass through the Lüneburg lens, they intensify the strength of the reflected radar signal. As a result, the radar cross-section, RCS, of the drone appears significantly larger than its actual size. Because of this enhanced radar reflection, Lüneburg lenses are widely used in radar reflectors, making weapons appear more detectable to radar than they actually are. In the past, Lüneburg lenses were difficult to manufacture due to their complex multi-layered structure. However, with the advancement of 3D printing technology, modern Lüneburg lenses can be quickly and cheaply produced using plastic frames. This means that a simple plastic sphere, no bigger than a fist, can allow a plywood and foam-built drone to appear on radar as a large military UAV. At this point, we've learned how these decoy drones are designed and how they deceive Ukrainian radar systems. However, how can they be effectively neutralized? Fortunately, countering these decoy drones is relatively simple. Decoy drones are cobbled together from cheap materials, making them far less sophisticated than Shahed series suicide drones. Unlike real combat drones, they have almost no resistance to electronic warfare, EW. A basic electronic jamming system is enough to disrupt and disable these decoy drones, causing them to lose control and crash. Meanwhile, actual suicide drones carrying warheads are designed to be more resistant to EW interference. Currently, Ukrainian forces have already deployed electronic warfare measures along the front lines and at key strategic locations to jam and mislead these decoy drones. Previously, 2 Russian decoy drones crashed in Moldovan territory. However, whether this was due to Russian navigation errors or successful Ukrainian electronic warfare countermeasures remains uncertain. The origin of these decoy drones has been investigated by multiple media sources. According to reports from Russian media and leaked internal emails from Iran, these drones are produced in a factory located in the Alabuga Special Economic Zone, east of Kazan, Russia. Satellite imagery confirms that after Russia's full-scale invasion of Ukraine in 2022, this factory underwent expansion. Several departments shifted to military production, with new buildings constructed and existing facilities renovated. Alabuga is Russia's largest industrial economic zone, accounting for 61% of the total revenue from all 24 Russian economic zones in 2016. Given its industrial capacity, it makes sense for Russia to establish a drone production facility there. However, what shocked many investigators was who was actually assembling these drones. According to an Associated Press AP investigation, the drones produced at Alabuga are not actually built by Russians, they are assembled by African migrant women. To address wartime labor shortages, Russia has been actively recruiting young female workers from Uganda, Rwanda, Kenya, and South Sudan. Russian recruiters advertise on social media, promising a free plane ticket and a European travel experience in exchange for completing a simple computer game test and memorizing 100 Russian words. However, once these women arrive in Russia, they quickly realize that the promised European travel experience and financial rewards were a scam. Instead, they are forced to work long hours in Alabuga's drone factory, earning meager wages. Most interviewed workers stated that their living conditions did not match their expectations. The originally promised salary of $700 per month was reduced to less than $500. At this point, it is clear that Russia's recruitment tactics closely resemble those of fraudulent labor schemes.